lesson, we're going to look at the gradient of a line. Okay, and so we're going to find gradients of lines using a variety of ways. And there's actually two parts to it, but this one, we'll get through what we're going to get through. Now, essentially, gradient means slope. Gradient equals slope. Okay, so slope is more the colloquial way that we say something. But if we say that the hill has a very steep gradient, it means that it's graded like it's a very steep slope. So gradient is slope. All right, now let's find a gradient. Now what's these 2 points here? Well, let's look at them. It's 2, 1, because x and y, okay? And this one will be 4, 3 it looks like. And yeah, crawl, climb, and there we go. Okay? So to find the gradient, there's a couple of ways we can do it. We can do what we did with looking at distance, is that we can just see how much it rises and runs. So gradient, the symbol for it is m, it rises over run. And in this case, it rises from 1 to 3, so that's 2 over, and this gap is 2 as well, so that's 2, so the gradient equals 1, okay? Now, that's not the only way that we can do it. We can actually use a formula for it, so let's have a look at a formula. So the gradient equals, now remember it's rise. Now, in the Cartesian plane, what goes up? It's y, so it's going to be y2 minus y1, and then what runs, it goes this way, is the x-axis, so then it's x2 over x1. And so let's just put our coordinates in there. Actually, I probably should give them values, so let's go x1, y1, x2, y2. It actually really doesn't matter, we just got to keep it consistent. So in this case, y2 is 1, y1 is 3, x2 is 2, x1 is 4. So we've got minus 2 over minus 2. We can cancel out these, and we end up getting the same gradient, m equals 1. So just to reiterate what we've done, we can just plot it on the graph and look how much it's risen and it's run, and we can find its gradient that way. Or we can use our gradient formula, which just, it's plug and play. You just punch it in and you get the formula as it is as well. All right, let's look at more examples. Okay, let's talk about parallel lines. Parallel lines are lines, these are parallel lines, but there are lines that have exactly the same gradient. Now, both these are the equations of the line, and they're written in this form. Now, m is exactly the same as what we used here, which was just gradient, okay? So the number in front of the x is the gradient, and this is the y-intercept. And you can clearly see that because here the y-intercept is 2, and there it is in the red one, and in the green one it's minus a half, and yep, it does look like it's minus a half as well. Okay, so we can see that both these lines, we can visually see it, but we can also see it from the equation that they have the same gradient. So we can say lines with same gradient are parallel. Okay, and you can clearly see it there. Now there's one more way that we can look at the gradient. We can just go rise over run. So it runs once this way, runs once, and it goes 1, 2, 3. So the rise of that one is 3, the run is 1, which is exactly what that is. And let's see if we can build another triangle of the same magnitude here. So I don't know, I'll pick here. It runs 1, and it goes up 1, 2, 3, and it also has the same gradient. Okay? All right, so parallel lines. Now, parallel lines, very similar concept is perpendicular lines. You can see here that these two lines are perpendicular to each other. So that means they're at a right angle to each other. Now, the way that we look at it is that this gradient is 3, and this gradient is negative a third, okay? So for lines to be perpendicular to each other, it has to be the negative reciprocal of it, okay? And we start off with going M1, so let's say that's M1, and that's M2. M1 times M2 equals 1. Therefore, M1 is equals negative 1, is equal to negative 1 over M2, okay? So in this case, what was M1? 3. And so for it so essentially if we have a gradient, I'm just trying not to confuse you. If we have a gradient, so say we have another line, y equals 4x plus 3, a perpendicular line would be y equals minus 1 over 4x plus whatever, okay? So see how that gradient is the negative reciprocal of the other one, okay? All right, that's the end of this lesson. Peace out.